Page 14, example 7. Now, the first part, A, find cosine ACD. Part A. Cosine ACD over here. How do we approach that? Find ACD first. Okay, so this is your approach. Step 1, find ACD, angle, is it? How to find? By taking cosine inverse, what? Negative 5 over 7. Okay, but when you take cosine inverse negative 5 over 7, what angle are you finding? So you mean you want to find this angle, is it? Then what do you do? Then 180 minus this one to get this one, is it? And then what do you do? No, they want cosine ACD. They don't want the angle ACD. Then you find AD using the angle, is it? Then you find this one, and then what do you do? Then you Pythagoras to find AC, is it? AD is 7. No, they didn't say that. Okay, are you following the proposal by our classmates? You understand what they're trying to say? So see, they are saying that, hey, let us take cosine inverse of negative 5 over 7 so that I can find angle ACB. Then I take 180 degrees minus ACB to get ACD. Once I get this angle, I can use tangent to find AD. Wait, that's not what you all said just now. No, not everybody knows. Okay, so once you find this angle, use Pythagoras to find AC. Then after that, you take, to find cosine ACD, just take adjacent divided by the hypotenuse. Sounds like many, many steps involved. So is there a faster way? Yeah. Who knows the faster way? Raise your hand. Only 2 of you. Okay, please share the faster way. What is the faster way? Jia Hao? Yeah lah, you say you know what? Find ACB. How do you find ACB? So you still want to find cosine inverse negative 5 over 7?
Then you 180 minus the one, then you cosine the answer.
No.
Yes, it's 5 over 7.
I mean, I got a faster way.
Because negative 5, because the other one is A.
Okay, can you all please look at this formula over here and think? I give you some time. A highlighted formula. Okay, question 1's ACD. So cosine ACD equals to negative cosine, I'm using the formula right now, 180 degrees minus ACD. All agree?
Yes.
Now what is inside this bracket? 180 minus ACD. Which angle do we get? ACB. What is cosine ACB? It's given to us, right? It is negative 5 over 7. Therefore, the answer is 5 over 7. Okay. The reason why we can use this is because there is a relationship between theta and 180 minus theta. What is the relationship between an angle theta and 180 minus theta? What is the not exactly, something more basic. An angle theta versus another angle which is 180 minus theta. Ying Zheng. What is the relationship between these two angles? X versus 180 minus x. I let you fill in the blanks. They lie on the same. Okay, they are adjacent angles on a. They are adjacent angles on a. What? Yes, they are adjacent angles on a straight line. Makes sense, right? Because add them up, you get 180 degrees. So here we have one angle and the other angle. They are adjacent angles on a straight line. Which means when you see this, you can apply this formula over here. Alright? Then, like I said, we can do this in one step. That is, I look at the value. Since cosine ACB is negative 5/7, my answer is simply negative of the answer. Negative of negative 5/7. Which means, in summary, I just change the sign. If it is positive, you got negative. If it's negative, you got positive. Clear? Yes.
Let's look at like it's supposed to be B instead of B.
180 minus the first line angle AC.
No, look carefully, it is not wrong. The presentation over there is slightly different from mine. Hey, wait. Yeah, it is not wrong. Look, they didn't have a negative sign in the first step. Okay? But it still works. Okay, distance between A and D should be straightforward. You can use your Sec 2 trigo. So don't want to go through that. Now your turn to go and try it 7. Very similar type of question. 4/9. That's it. And part B, can you do it by yourself? Okay, because it's Sec 2 work. So let us move on to exercise 7.2. Remember I asked you to do your homework on full scale paper, right? 7.2. Let's continue on that same paper. Question 8. Question 8, we will practice a little on our converse of Pythagoras theorem. Question 8a. Okay, read the question. Okay, the approach is to use converse of Pythagoras theorem, but what is my first step? A B square plus BC square. Okay, must be like this, and what do we have?
Equals to 4,235.
4, 2 what?
225.
4225. Okay, then what is the next step?
AC square equals to 65 square.
Okay, and how much is that?
4,225.
Okay, then?
And by converse of
Okay, wait, not yet. You write
A
equals to AB square plus BC square. Now we have already proven that AB square plus BC square is AC square. Therefore,
angle ABC is what angle?
by the converse of Pythagoras theorem, you must spell it out.
Triangle ABC.
Not exactly triangle ABC.
How do you spell Pythagoras?
I don't know, that's why I don't want to spell it out. You caught me, but you need to spell it out. We'll find out. Okay, so by the converse of Pythagoras theorem, angle ABC is 90 degrees. Okay, you must write all these. It shows that angle ABC is 90 degrees. And this therefore implies that the triangle ABC is a right angle triangle. Okay? So I want you to be clear, there's a difference between saying that angle ABC is 90 degrees versus triangle ABC is a right angle triangle. Okay, so let me just put it down in words. Angle ABC equals 90 degrees versus triangle ABC is a right angle triangle. What is the difference?
That means ABC is a right angle triangle
Can be like ACB, AC.
Okay, so this may be ABC equals to 90 degrees. What else could it be? ACB equals to 90 degrees. BAC equals to 90 degrees. Right? So there's a difference between these two statements. Our converse of Pythagoras theorem tells us very clearly that angle ABC is 90 degrees. Why? Okay, because originally our Pythagoras theorem, it tells us that if this is A, B, and C, if this is A, B, and C, Pythagoras theorem tells us that the sum of the squares of the two shorter side equals to the square of the longer side. And the longer side is always opposite the 90 degrees. Therefore, when you use converse of Pythagoras theorem, you are very clear about which is the 90 degrees. Okay? By writing, therefore ABC is a right angle triangle, it is a little ambiguous. Okay? Okay, so that is for part A. Now part B, you are supposed to find cosine ACD. So part B, cosine ACD equals to? This is the correct answer. But how do you get it so quickly? Okay, so in your mind, you should be thinking this. Cosine ACB equals to 56 over 65. This one over here. So since the blue and the black angles, they are adjacent angles on a straight line, we can use the same relationship, which is cosine theta equals to negative 180 minus cosine theta. So since this is 56 over 65, I change the sign together. Answer for cosine ACD. Understand?
You can present your work like that.
Yeah, you can present your work just like that.
Oh wait, that kind of mark is 1 mark only.
Yeah, 1 mark only. Okay, if there are no issues, let us move on to the next question, 9A and B. Huh? Go where? These are the homework questions. Okay, next one, question 9A. Got a trapezium. A, B, C, and D. Find the length of BC. How much? How can it be 441? 21. Do all of you have that? No need. No need write by Pythagoras theorem. This is okay. Can? So this being 21. Let us now do part B, which is to find cosine BAD. Okay, then? How does this help me? You want to draw a rectangle.
So can expand the other line.
Extend which line?
The one that is
At D. Okay, vertical line from D down, right?
oh my god.
Like this?
So many ways. No, the one in the middle.
The one in the middle.
Yeah, the one you use to in between D and C.
In
That
between D
line,
and C,
extend it all the way down.
extending all the way down.
Yeah, that's why.
Like this?
Yeah, like that.
And then?
And then you find. Then you go 21 and
21 and 29. How? Which angle are you looking at?
I don't want to explain.
Okay, so listen to what I said earlier on. When you have this type of question, cosine BAD, where BAD is obtuse, I want you to find another angle that is adjacent to it, and they form a straight line. So where is the angle that is adjacent to BAD on a straight line? This one. Alright? So if I can find cosine of the red angle, I will be able to flip the sign and get the answer for this. Agree? Okay, so how to find cosine of this red angle? Is it very clear? Okay, what is the adjacent length? So this is 20. What is the opposite length? This is 21, right? Then the hypotenuse is 29. So cosine BAD must be equal to negative. Okay? Right, Zachary? Okay, so that's for part A and B already. Done. So these are your homework questions, which you have already done. And now flip to revision exercise 7. Just 2 more questions to make sure that we really know how to tackle all this really quickly. Okay, revision exercise 7, question 3a. That is on page 39. Therefore, we write BAD, right? BAD. We write AB square plus AD square is 35 square plus 12 square. Tell me what's the value? What do I get?
1,300.
Okay, then we write BD square equals to 37 square, which is 69, which is the same as AB square plus AD square. Then by converse of, need to spell or not? Yes. So which angle is 90? Angle BAD equals to 90 degrees. So that's part A. Now part B. Find cosine BDC. BDC. Okay. Answer? Cosine BDC? Negative? Negative 12 over 37. Who needs help for this? Who needs help for this? Come on, don't be shy, raise your hand. Okay, so here we have a triangle. Okay, this is supposed to be 90, yeah? We have proven it already. So this D, 37, 38, C, B, 35, A, and 12. Okay, cosine BDC. BDC, this yellow angle over here. Cosine of this angle is equal to negative of cosine this angle, isn't it? Because they are adjacent angles on a straight line. So since this triangle is a right angle triangle, I can apply the trigo ratios that we used in Sec 2. We learned in Sec 2. So if I do not skip steps, this will give me equals to negative cosine 180 degrees minus BDC. Right, this is the direct application of the formula. This is equal to negative cosine 180 minus BDC will be BDA. This is our angle in green. Agree? Okay. So cosine of the angle in green. Let's put a negative first. This negative just carry it over. Okay, so negative cosine of the angle in green. Cosine adjacent over hypotenuse. What is the adjacent length? 12. And what is the hypotenuse? 37. That's it. Okay? So continue to be able to see what are the adjacent angles on a straight line. Okay, then I believe there's one more question. 13. C, part 1, part 2. Okay, please try 13C right now. Negative 3 over 5. Because the question already gave us that ACD, cosine ACD is 3 over 5. ACD and angle ACB, they form a straight line. Therefore, the cosine value of this angle must be negative of the previous cosine value. Okay? Look at the question and write down the answer. That's it. So you must be able to recognize that. So next one, part 2. Sine ACB. What I'm writing in black ink is not the length. I am writing ratio of cosine, right? So this is adjacent to hypotenuse. So what I'm going to write down in black is just ratio. It is not the exact length. Okay, so adjacent side being 3, hypotenuse being 5. What then do I require for the other unknown side? Take note, what is in black is just ratio. It is not length. Lengths will be in red, 21 and 14. So this can find the side, the perpendicular height. How much is that? 4. It is a ratio, it is not a length. Okay, so based on this, I can write down that sine ACB is equal to sine 180 degrees minus angle ACB, which if you memorize, you don't need to write down already. It is actually sine, which angle is this? 180 minus ACB. AC? D, yes. So there are these two adjacent angles. Sine of both of them are the same, yes? And what do we have? Sine ACD. 4 over 5. Okay? So this is the relationship between sine of two angles, where the two angles are adjacent angles on a straight line. They are the same. As compared to cosine, the magnitude is the same, but the sign is different. Okay? So that's all for this part. And that's all for your homework. Anyway, do I have more homework question? Okay, so please take down this extra homework question, which is 6 and 7, to be done at home. Due tomorrow, just 2 questions. This exercise 7.2. Questions 6 and 7. Just practice only. Yeah, they are no need working one, just write down the answer only. Yes, on the same foolscap. Okay. Now let us move on to 7.3. It is the formula for area of triangle. What is the area of a triangle formula? Half times base times height. Where height, this h over here is the perpendicular height from the base to the other vertex, right, of the triangle. Okay, good. Now, if I give you a diagram like this, I give you the length of A. Given A and B. And included angle. What does this statement sound like? Which topic does this sound like? I give you A, I give you B, I give you included angle. SAS, right? What topic is that? Yeah, similarity and congruency. Which one exactly is it? Congruency, right? Based on these 3 pieces of information, I can draw a triangle. Do you agree there is only one triangle that can be drawn? Because once I know the length of A, I know the angle between A and B, I know the length of B, there is only one triangle I can draw by joining these 2 lines up, these 2 points up, right? So I get a triangle. Therefore, it means that if I give you the length of A, I give you the length of B, I give you the included angle, I can find the area of this triangle. Because there is only a unique triangle you can draw. So, I am able to find area as well as perimeter. Okay, because we are restricted already. There is only one triangle we can draw. Only one answer. So I must be able to find the area and the perimeter. So today I will teach you how to find the area of this triangle when you are given A and B and the included angle. Are you all ready? Not difficult, huh? But I need to introduce you to some things first. I will use small letters to represent length. Okay? So if this is A, this is B, what should this side be called? C lah, small c, okay? Then I will introduce you to the points of the triangle. Usually you use capital or small letter for the points. I use capital letters, right? Your quadrilateral A, B, C, D. Your trapezium, X, Y, W, X, Y, Z, so on and so forth. We use capital letters. So over here, I am also going to use capital letters. I will use A, B, C. Okay? Where should I put the point A? Should it be 1, 2, or 3? Where should I put point A? No, I will put point A at over here. Okay? The reason is because I want to put the point A opposite the side. Get it? So this is how we usually do it. This is how we usually label it. And that's the reason why I want you to know this way of labeling. Now, where is point B? 1 or 2? 1 lah. Okay, so this is point B. And very unfortunately, we have been using it like this. So what is the confusing part? Yeah, small c, big C look alike, right? So just try to make the big C really big C lah, small c, okay? Yes. Why must use ABC? Why not use X, Y, Z, right? Okay, later at the end of the lesson, you will see why. Okay, right now, the goal of this is to find the area of the triangle. Based on what we have already learned in primary school, if I have the B for base, what else is required to find the area? Height. Where is the height? From where to where? Okay, B to CA. So this is my H, isn't it? Now, I forgot to tell you that when we write the points A, B, and C, what should we call this angle over here? What is this angle called? Angle BCA or angle ACB. But sometimes, very rarely, we take a shortcut. We call this angle C. Okay? Then what should we call this angle over here? Angle A law. What about this angle? Angle B. Okay? So, using this convention, where this is angle C, I want to now write an expression for H and A and angle C. Can you form an equation using angle C, A, and H? Okay, equation for angle C, small a, and H. Okay, what is the equation? Sine, a trigo ratio. Sine C, so I write a big C, Sine C equals to H over A, right? Agree with this? Okay, so earlier on I said that when I want to find the area of a triangle, I require the height. So what do you want to make as the subject right now? H, obviously H. Okay, so H equals to A sine C. Agree? So I put this back into my equation over here. What we learned in primary school, half times base times height. Therefore, the area equals to half times B times A sine C. Okay? So like I said, earlier on when I introduced this topic, we didn't have a height. However, I gave you the side A over here. I gave you the side B as well as the included angle C. With these three pieces of information, I can find the area of triangle. And what is the formula given? What do we have? Half times B times A times sine C, right? So it sounds like a mouthful, so we rearrange it a little bit to make it easier for us to memorize it. We call it half AB sine C. Okay? Easier to remember? Half AB sine C. And that is what every single Sec 4 student taking the O-levels must memorize. Half AB sine C, half AB sine C. Where A and B are lengths, and C will be an angle. Obviously, you sine an angle. Okay? So that is why we, to answer Kevin's question, why must we use C? Why not use X, Y, Z? So that there isn't a confusion. Because we want to be able to say it very easily like this, half AB sine C. Okay? Any questions on the derivation? Okay, now I want you to give me an alternative formula for the area of this triangle. Instead of half AB sine C, what other variations are there? Area also equals to half. A BA sine C is the same as AB sine C. Give me another one. C, B, sine A. Good. Which is also equal to half. half AB sine C is here already.
half AC.
Half AC sine B. Okay, do you see that all these are different? A, B, C. Then we got A, B, C over here. Then once you have two sides plus included angle, you can find area of triangle. Any triangle. Then obtuse angle triangle can or triangles that look like this. So can. Let's use the same thing on B over here. A and this is the point C. So this must be A, this is small c, and this is B. Okay, so I give you, so let's say we have this angle C. What is the area of this obtuse angle triangle? Based on our primary school knowledge, I require, if B is the base, I require this one, right? H. Right? So how to find H? How to find H using the same approach? I've got a right angle. I've got A over here. I want to include the H over here. Which angle is important for me? Okay, this is why we avoid saying C lah, okay? The blue color angle is important, right? Because, let's call this blue angle theta, okay? So now, sine theta equals to opposite. What is the opposite? Opposite? H over A, yes. Now, H again is equals to A sine theta, isn't it? Then sine theta, but in my original triangle, I don't have theta, but I have angle C. Is there a relationship between sine theta and sine C?
Yeah.
What is the relationship?
Adjacent angle.
They are, okay, theta and C are adjacent angles. Therefore, sine of these two angles must be the same, which is A sine C. Okay, so the original formula is area equals to half times base times height. Half BH, right? Then now I've got an expression for height already. Let's put it in. And I get half times B A sine C again, which is half AB sine C. Okay, so the same formula can be used. In summary, I don't care what your triangle looks like. Whether it is a triangle that looks like this, an obtuse angle triangle, equilateral, isosceles, whatever it is. As long as you have one side, two sides, and the included angle, I can find the area by using half AB sine C. Okay? So we will practice one question, simple one. Try 8. Area equals to, which is known as the included angle. So what do we have as the answer? How much? 16.1. Give me 5SF first. 0.86. So
the one removed.
yeah,
0.
0, 8, 6, 9. So 8, 7. Okay, so we round it off 3SF 16.1 square centimeters. Alright? So your homework for this topic is to do try it 9. Okay, you can do this on the textbook, but there's a trick for try it 9. I see whether you all will catch it or not. Okay?